Hello, welcome back. This is the final step, video number 8, hopefully the last video in the tutorial for MAPP assignment number 4. This is MAPP 3D assignment number 4 for Speaker Systems Design and Optimization, the course at Husson University. So in the last video, we completed the process of level time aligning for equal level, equal time at the center of the venue, orchestra center. And now we're going to kind of repeat the process, but do it at the left mic, which is in the left seating area. And the theory here is that if you align the left array in time with the subs, since it'll be symmetrical on the right side as well, you may get a better coverage pattern than we achieved when we aligned the center of the venue for equal level, equal time with the sub. So let's just see how that works out. So I've simplified the instructions. We're not going to go into as much great detail as I did in the last time, in the last videos. I'm going to kind of whip through this as fast as I possibly can. Side note, this is a really good time since we're starting with a new file here to double check to make sure the array correction portion of the processing is still correct. As of summer 2025, this portion of the software is buggy, and when I reload a file, it keeps turning off array correction for the main channel. So I'm going to turn that back on because I have reloaded the file. So if you may want to double check to make sure your results are going to be consistent and look like the images I produce. Also, the thing we want to do is delete any processing we put on the mains and subs to align them in time. So I'm going to get rid of the delay I added to the mains, and I'm going to unreverse the polarity of the mains. The subs we brought down in level by a dB, so I'm going to restore that. So we're kind of basically reset for the level and time alignment process. The other wacky thing we're going to do right now is hide the right mains. We're only going to align the left mains and the subs in time and equal level here. It's debatable whether this is the best solution. Alternatively, you can do equal level, equal time with both the mains on. You'll see quite a bit of combing over here because the late mains from the right will interact with the left. That will get you different results. You'll have to you'll have to set for equal level through that combing and trying to figure out what to do. So I'm not saying which way is better, but right now we're just going to do it to make it simpler and faster. I'm going to turn off the right mains so they're not visible, so we won't see their interaction on their combing in the amplitude results. So all that said, right mains muted. Make sure you move your microphone to orchestra left, so you're using the microphone that's closer. And next thing to do, let's mute the subs. Let's figure out, I'm going to select the processor and mute the subs. Mains only here. I want to find out what the level of the mains is at the crossover point 80 hertz. I'm zooming in. I'm going to make sure I set for the lowest frequencies only to kind of improve the resolution here. And I'm going to slide down to 80 hertz. And oops, I was looking at the wrong number there. It's so easy. And there we go, 80.1. It's 95.6 dB, 95.6 dB. If we look at the subs only, look at 80 hertz. It's 100.1. So it sounds like we need to turn the subs down about 4.5 dB at this particular location. So let's try that. Let's turn the subs down minus 4.5. And I got to turn both subs down, front and rear. And now we get at 80 hertz, 95.5. 95.5, and on the mains there, just double checking my work here, at 80 hertz, I've got 95.6, so very close. Now, side note, if we had the right mains on right now, we would get a very different result for this mains level, but it would actually be very comey and ripply. So because of the space mains. So, you know, again, that's an alternative approach to doing this. So with this done, we now have equal level for both the mains and the subs. We've turned down the louder section of the system, which is the mains. Sorry, the subs. Let's take some traces. First trace we're going to take is the mains at left mic. So let's zoom out and make sure we're looking at the right thing here. Full range. We are definitely looking at the mains there, and look at other things. And before I take that trace, I'm going to align the prediction here. I'm going to auto-align the mains to the center for propagation delay, and cleans up the phase trace quite a bit. And let's take that trace now. Store live trace. This is going to be mains at left mic. Make it visible for the moment. Let's turn the mains off and take a trace of the subs. Let's predict. There's the subs. A lot of wackiness in phase because they're pretty out of time there. Let's zoom in once again. We can just see they are pretty much equal level. Let's store this trace. This trace is going to be subs at left mic. And we've got them now. And I'm not going to make that visible because we're seeing the subs through the live. Now let's analyze our data here a little bit. Zooming in on phase trace, you can see the blue, the subs is quite a bit steeper. So that indicates it's later in time than the mains. And that actually makes complete sense because you're sitting over here and the subs are way over there. So you're hearing the mains energy before the subs energy. So it makes sense that you would see the subs quite a bit later, i.e. steeper. And over here in the impulse, you can definitely see the impulse is much later. So we're going to need to delay the mains to some point in this impulse here where 80 hertz occurs. And we found out earlier that 80 hertz kind of line is in this area. So we're going to need to delay the subs quite a bit. If we zoom in here, you know, it's going to need delayed at least 10 milliseconds, right? Because over here's where the subs start. So somewhere in this area of delay is going to be necessary. So that kind of helps us by interpreting here. We don't have to go through the process of adding 1 millisecond at a time. Maybe we can jump to a slightly larger amount of delay when we're going through the delay process. So we're needing to delay the mains. We're going to want to see the stored subtrace we just took. Hide the mains trace. And we're going to want to listen to the mains because we're going to be adjusting the mains. So here's the mains. And let's look at the phase trace. And again, you can see the red one here. I'm sorry. The blue one is the subs are in brown. And you can see the mains need quite a bit more delay to be later here at our crossover frequency. So let's start adding delay. As I said earlier, we can go a little bit higher. Let's start with 5 milliseconds. And if I hit enter, it just automatically predicts, which is awesome. And you can see I'm quite a closer there. I'm going to go in intervals of 2 milliseconds. And ooh, we're pretty close there with 7 milliseconds right now. I mean, they look very, very similar. Of course, our target alignment target of 80 hertz is right there. I'm pretty sure that's it. Like, I mean, half milliseconds are kind of silly, but sometimes it's satisfying to see if it's a little better. Nope, it's worse. Let's try 6.5 milliseconds. Oh, that looks great, right? I would say those are in time, in phase. So we did it. We figured out 6.5 milliseconds. We zoom out here and look at the other things in the measurement window. You can see we have definitely pushed the impulse later, but we're in time there. That looks pretty good. Let's check back to the instructions if there's anything we're supposed to do here. We're supposed to analyze. We've gone through this whole process. We've gone through the time aligning. I guess it's ready to see results. So going to the model view, and I'm going to go to isometric. Let's definitely bring the right mains back into the game here. Now we'll see all the combing that results between the left and right mains. Actually, we'll have combing between all three now. Let's open up the subs. So all three systems are ready to go. Let's hit predict. And that's what we get. Huh. I was expecting for a brighter alignment, a louder alignment here, but that might have been because I didn't have both systems on when we did the calibration. Looking top down, you can kind of see what it looks like. Interesting. Now, is this better? It's hard to know. Take a screenshot of this, take a screenshot of it, and that's what I've done here, and you need to name that screenshot left aligned your name. That's your final screenshot, I believe, for this class. Nope, there's one more screenshot. And here's a comparison between unaligned. This is equal level at the center, but not equal time at the center. This is equal level and time at the center. And this is unaligned. This is aligned to left. I'm not sure which one gives you the best and most evenest coverage across the venue. I think the unaligned does, which is funny. I've had this experience in person in the Gracie when doing time alignment with Smart, that the time alignment really doesn't help out very much. As your final screenshot, please capture this entire measurement view window. That's what I said, right? Yeah. Call it left aligned measurement, this entire window. This way I can see the nice clear phase trace you've created by putting them at equal level. By the way, there's that combing between the mains now. And you got to package all this together. You should have in the end a ton of screenshots here. You should have two files, a map center aligned your name and a map left aligned your name. You're going to take those and put them in a folder. You're also going to have screenshots of various predictions. You're going to have cardioid subs, center equal level, center aligned, and left aligned. And you're going to have two screenshots of the measurement viewer, the center aligned and the left aligned. All of this is quite a complicated assignment. All of these files are put in a folder, compress the folder, make a zip file out of it, name the folder map for your name, and upload this to Canvas for my feedback. Thank you for bearing with me. This is a long assignment. A lot of videos and a lot of complexity, but aligning subwoofers and mains is not easy. Keep in the back of your mind, the whole thing might be kind of pointless. At least in this particular situation, the results were ambiguous at best about what the best choice is, but the industry as a whole is very obsessed with subwoofer alignment, so it's important you understand how to do it, in this case, in the virtual environment. I hope you're well. Have a great day. We'll talk soon. Goodbye.